Let us continue ionic equilibrium. Now we will compare ionic product and solubility product when precipitation is possible. That point we will see. Now we will take a silver nitrate solution. Silver nitrate solution we are taking. Silver nitrate we are taking this many moles. This many moles of silver nitrate solution we are taking. Silver nitrate this many moles. 1 liter solution we will take. Then we will take sodium chloride solution. In sodium chloride solution, sodium chloride present this many moles. This many moles of sodium chloride is present. This solution is 1 liter. Let us mix both solutions. We will mix. We will get a resultant solution. In resultant solution, volume is 2 liters because it is 1 liter. This is 1 liter. Adding is 2 liters. We are getting. We will get Ag plus ions in the resultant solution. That concentration we will see. Ag plus ions. Number of moles is 2 into 1.34 into 10 to the power of minus 5 moles. Volume of resultant solution is 2 liters, which is equal to concentration of Cl minus. This equal to 1.34 into 10 to the power of minus 5 molar. Concentration of Ag plus and concentration of Cl minus we got. Now we will write in the resultant solution, we will write an equilibrium. AgCl solid gives Ag plus aqueous and Cl minus aqueous we will write. Now we will write ionic product of AgCl. Ionic product of AgCl is AgCl equal to concentration of Ag plus into concentration of Cl minus. Let us substitute the values. Concentration of Ag plus is 1.34 into 10 power minus 5. Concentration of Cl minus is 1.34 into 10 power minus 5. Let us multiply both. We are getting 1.7 into 10 to the power of minus 10 molar square. It is ionic product of AgCl. Now we will see solubility product of AgCl. Solubility product of AgCl is how much in the sense 1.7 into 10 to the power of minus 10 molar square. In this case, ionic product is equal to solubility product. Therefore, the resultant solution is what in the sense saturated solution. The resultant solution is called a saturated solution. In the previous case, in the previous day, we got ionic product is less than solubility product we got. Ionic product is less than solubility product in the sense we said the resultant solution is called unsaturated solution. Unsaturated solution. Unsaturated solution means the solution is able to dissolve still more amount of salt. This solution, unsaturated solution means this solution is able to dissolve still more amount of salt. Saturated solution means this solution is having enough dissolved salt. It is unable to dissolve any more amount of salt. That is called saturated solution. Now we got ionic product is equal to solubility product. That means the resultant solution is saturated solution. Saturated solution means in the resultant solution enough amount of dissolved salt is present. Now you say that in this solution dissolved salt will precipitate or will not precipitate? Dissolved salt will precipitate or will not precipitate? In this solution enough amount of dissolved salt is there. Therefore, dissolved salt will not precipitate. Therefore, in this place, precipitation is not possible. Precipitation is not possible. In the unsaturated solution, this solution itself wants to dissolve still more amount of salt. Then how to expect it will precipitate the dissolved salt? We cannot. Therefore, in this place also, precipitation is not possible. Therefore, in saturated solution, no precipitation. In unsaturated solution also, no precipitation, we can say, sir. Now we will take a silver nitrate solution. We will take silver nitrate solution we are taking. This is how much in the sense 4 into 1.34 into 10 to the power of minus 5 moles silver nitrate. 1 liter solution we will take. Then we will add sodium chloride solution into this. That is how much in the sense 4 into 1.34 into 10 to the power of minus 5 moles. This is 1 liter. Now let us mix both. We will get a resultant solution. Resultant solution is 2 liters. 2 liters resultant solution we are getting. In this resultant solution, Ag plus ions is present. Ag plus ions, that concentration is how much in the sense number of moles we will write in the numerator, number of moles. In the denominator we will write volume of solution. And this is same like a concentration of Cl minus, it is equal to how much in the sense 2 into 1.34 into 10 to the power of minus 5 molar. So we got concentration of Ag plus and also we got concentration of Cl minus. We got Ag plus concentration as well as Cl minus concentration, we got it. Sir, okay. Now, what shall we do in the sense, we'll see whether AgCl precipitates or not. For that, we'll take ionic product of AgCl. Okay. So now first we will write ionic product of AgCl, then we will say precipitation is possible or not. Now ionic product of AgCl is equal to concentration of Ag plus into concentration of Cl minus. Let us substitute this Ag plus concentration, that is 2 into 1.34 into 10 to the power of minus 5. Cl minus concentration also we are substituting. So we are getting ionic product of AgCl, that is how much in the sense 4 into 1.7 into 10 to the power of minus 10 molar square. Now we will take solubility product of AgCl. Solubility product of AgCl is equal to 1.7 into 10 to the power of minus 10 molar square. Now in this case, ionic product is greater than solubility product. So, ionic product is greater than solubility product in the sense the solution is not resultant solution. The resultant solution is not saturated solution. So in this place, we got ionic product is greater than solubility product. That means the resultant solution is not saturated solution. So that means the system wants to become saturated solution. Ionic product is greater than solubility product here. Therefore, the resultant solution is not saturated solution. Therefore, the system wants to become saturated solution, for which system will try to make ionic product equal to solubility product. In order to do this, system will try to bring ionic product to lower. How the system makes ionic product to lower in the sense by bringing down Ag plus concentration and Cl minus concentration. So system brings down Ag plus concentration and Cl minus concentration such that it brings down ionic product becomes equal to solubility product. Sir. Therefore, what system does in the sense, system decreases concentration of Ag plus. What does it mean? System, how can the system decrease Ag plus concentration? That means system removes Ag plus aqueous. System removes Ag plus aqueous as well as Cl minus aqueous. How system will remove Ag plus aqueous and Cl minus aqueous? System removes Ag plus ions from the solution, as well as system removes Cl minus ions from the solution. It is removing from the solution means, that means system makes Ag plus aqueous to go out from the solution. Similarly, system makes Cl minus aqueous to go out from the solution. In that means in what way it removes in the sense system makes Ag plus aqueous and Cl minus aqueous to become solid. So Ag plus aqueous, Ag plus from solution and Cl minus from solution becomes solid AgCl. It is precipitating. It is going for precipitation. So Ag plus ion is converting into AgCl solid in the sense AgCl solid is detached from the solution. It is not distributed in the solution. It is not present in the solution. It is separated from the solution. So in this case, system removes Ag plus as well as Cl minus by precipitating them. Therefore, due to this process, what happens to the concentration of Ag plus? Decreases. What happens to the concentration of Cl minus? Decreases. So the system, what system is doing in the sense, system continuously removes Ag plus ions from the solution. Therefore, Ag plus concentration continuously decreases, simultaneously Cl minus concentration, simultaneously AgCl is going on precipitating. Therefore, ionic product of AgCl goes on decreasing. When ionic product becomes equal to solubility product, at that time system becomes a saturated solution. System comes to equilibrium while system stops precipitating. While system stops precipitating, while system stops removing Ag plus from solution, similarly Cl minus. Therefore, in this place, when ionic product is greater than solubility product, while system is not in saturated solution, then system is in what manner? When ionic product is greater than solubility product, system is called a super saturated solution. The system is called a super saturated solution. Sorry. Super saturated solution is not possible under normal condition. Either it is possible at higher temperature or it is possible at lower temperature. Super saturated solution is possible in that way only, either at higher temperature or at lower temperature. So you have to take the solution to the either side of normal condition, then only you can prepare super saturated solution. Sir, so we got a super saturated solution. That means how to prepare super saturated solution in the sense this is not prepared at normal condition. Sir, we prepared super saturated solution. That means in this solution AgCl is dissolved AgCl is more than at saturated solution. For attaining saturated solution, how much AgCl to be dissolved, more than that will be present in this solution. Okay, so super saturated solution means a dissolved salt will be, how much will be there? More than the top saturated solution. So now that means system is not at super saturated solution means system is not at normal condition. It is not at room temperature and room pressure. So super saturated solution means one point is dissolved salt is amount of dissolved salt is more than that of saturated solution. Number two, conditions of super saturated solution is not at room condition. It is either side, either on side. That means either lower or higher when compared to room condition. So now ionic product is greater than solubility product. System will try to attain normal condition or not? Sorry, system is attaining normal condition means system wants to become what? Saturated solution. At that time system will get equilibrium. So system wants to get saturated solution in the sense super saturated solution should become saturated solution. What is the difference between super saturated solution and saturated solution? Number one, here dissolved quantity of salt. Dissolved quantity of salt is more here. Here dissolved quantity of salt is less. It is not at normal condition. It is not at normal condition, whereas it is at normal condition. Now that means now super saturated solution will not exist normally. If we go on maintain that required condition, then it will be maintained. It will present as super saturated solution, otherwise not. If we leave, then what it will happen? It will try to become normal condition. It is trying to become normal condition in the sense the super saturated solution becomes saturated solution. That means excess dissolved salt should go away from the solution. Excess dissolved salt is going away in the sense what is the way? Precipitating, converting into salt. Excess dissolved salt becomes solid. That means precipitation. Therefore, precipitation is possible. Therefore, when precipitation is possible, if ionic product is greater than solubility product. Now, you consider the crystallization. Crystallization in the sense, seawater, from seawater we are extracting salt. From seawater we are extracting salt. How we are extracting salt from seawater? Same this process. We are making ionic product of sodium chloride greater than solubility product of sodium chloride. Then what will happen? Automatically salt will be crystallized. In the sugar industry, uh, sugar juice will be extracted, sugar juice will be taken from sugarcane. Finally, before adding charcoal, bone charcoal, the sugar will be brownish color that is present in solution. That sugar solution is taken for crystallization, then only we will get sugar crystals. Taken for crystallization. Crystallization means what? Take the solution to supersaturated solution. Convert the solution to supersaturated condition. Then leave. Automatically supersaturated solution will become saturated solution. Then excess dissolved sugar will be there. No, that will be precipitated. Excess dissolved sugar will be precipitated. That's all. That means supersaturated solution becomes saturated solution in the sense, from saturated solution, can't we separate sugar? Yes, that saturated solution is called molasses. From molasses only we are preparing what? We are manufacturing ethanol. Sir, that means, so wherever we are coming across crystallization, we are making the solution into supersaturated solution. That solution we are converting into saturated solution. The excess dissolved salt is precipitating. Okay, sir. So for precipitation, what is the condition? The how ionic product and solubility product should be there? Sir, now we discussed three categories of ionic product and solubility product. One category is what means ionic product is less than solubility product, while resultant solution is unsaturated solution, while precipitation is not possible, we said. Okay. Next is ionic product is less than a solubility product over. Next, ionic product is equal to solubility product. That time resultant solution is saturated solution, while also precipitation is not possible. Next one is ionic product is greater than solubility product. At that time resultant solution is supersaturated solution, while precipitation is possible. So if we want precipitation, bring ionic product greater than solubility product, then precipitation is possible, we can say. So when precipitation is possible, if ionic product is greater than solubility product, then we can say precipitation is possible, we can say. Sir, next we will go for titration. Next we are going for titration. What is titration? Titration in the sense, minimum two solutions we are taking, solution 1 and solution 2. In this titration, what we are going to do in the sense, this solution 1 and solution 2 should react with each other. In this solution 1, concentration will be given. Solution 2, this solution 2 concentration will not be given. This we have to find. That is the aim of this titration. So in this titration means solution 1 concentration will be given, solution 2 concentration we have to find it. Okay. How solution 1 and solution 2 should be there means they should react with each other. Like this should be there. So for this, what are the instruments are required? What are the instruments are required that we'll see? One is called a burette. Next one is called a pipette is required. Next one is called a conical flask. Next one is called conical flask. Next one is called a, sometimes external indicator is required. Sometimes self indicator also available. Self indicator in the sense, this solution among these two solutions, one of them will act as indicator. Therefore, we can call them as self indicator, we can call. Sir, so these are the things required for titration. Burette, in the sense, it is the one of the instrument or one of the vessel. It is made up of a what, in the sense, glass vessel. It is made up of either glass vessel, otherwise plastic, mainly glass vessel. This burette is made up of what, in the sense, glass vessel. How this burette will be there? How this burette will be there, that we will see. Burette, in the sense, it will be present like this. This is nothing but a cylinder. This is nothing but a cylinder, just like pipe. Pipe is there, means how pipe is there? We are carrying water using pipe. No, like that pipe it is, but it is made up of glass. And in this place, how it will be there? Means in this place, like this will be there. Here hole will be there. Here cork will be there. In order to open, if you open the cork, the solution present in the burette will come down. We can make the flow of this burette solution controlled by this knock, by this top, this by the using this knob, we can control the flow of burette solution. Okay. Then in the burette, readings will be there. Suppose here 50 ml is given, and here 0 ml is given. That means from year to year, what is the volume of solution, in the sense 50 ml solution? That is the mean. Then this 0 to 50 ml is equally divided into 50 divisions in terms of milliliter. In terms of milliliter, they are equally divided. So using this burette, we can say how much solution we have consumed or how much solution to be added, that we can say using this burette. Sir, how the burette will be there, that we will see. We are seeing a burette is this one. This burette, it is made up of what, in the sense, glass vessel. Now see in this burette here, this is glass vessel. Here readings will be there. In this burette, readings will be there. And in this burette, you see here diameter is more. Here diameter is more. It is like a cylinder. It is just like a cylinder. Here diameter is more. Here you see diameter is less. And at the tip you see diameter is still less. Now it is a knob. Using this knob, we can stop the burette solution to come down, or using this knob, we can make the burette solution to flow down. Okay, so the burette is like this is present. Next we will see the burette stand. We will see how this burette will be fixed in the burette stand, that we will see. Now we have taken this is the burette. This is the burette we have taken. This burette we have fixed in the burette stand. In the burette stand we have fixed. Now this part, this place at down we have placed something. No, at down in the burette stand down we have placed something. You see, this is called a conical flask. This we can call it as what? A conical flask we can call. Okay, sir. Next we'll take this one. This is called what, in the sense, a pipette. This glass vessel is called what, in the sense, pipette. In this pipette, what will be there? Means here some red mark is there. No, that is called 0. That is called 0. Here and all marking is there. See, it is called graduated pipette. Graduated pipette in the sense here it will be the marking will be there. Marking in the sense up to this so and so volume, up to this so and so volume, like this we can say. Here at down also marking will be there. At down generally how much will be there means 20 ml will be there, or 25 ml will be there, or 10 ml will be there, like this. It is called a graduated pipette. Graduated pipette we can say. Graduated pipette in the sense here measurement will be calibrated. That means from year 0, year 1 ml, year 2 ml, year 3 ml, year 4 ml, like this values will be engraved. So we can say how much volume of solution we want, we can take and we can add using this. Okay, sir, how to take solution in this burette? In the sense we have to keep this part in between mouth lips. Then we have here this tip should be dipped in the pipette solution. Then we have to suck from using this. In this place we have to suck the solution. Then solution will be entering into this pipette. Solution from vessel entering into the pipette and comes to this place. The solution will go on come up on sucking the solution. When it comes up to this level, we have to stop sucking the solution. Then if we take the solution up to this level, that means the solution lower meniscus should coincide with this mark. Up to this we have to take. That means starting reading is 0 ml. Okay, then you take out the pipette from the pipette solution. Then take this tip into the conical flask and transfer this pipette solution into the conical flask. Okay, how much pipette solution you want, that much pipette solution you take in the conical flask. Okay, now in this conical flask we have taken the pipette solution. Okay, in this conical flask we have taken the pipette solution. Then in this burette we are taking the burette solution. Then indicator is required, means add indicator into this conical flask. Then start doing titration. How to do titration? In the sense open this knob. This burette knob is there, no? Open this knob, slowly you open it. Make burette solution 1 drop fall into the conical flask. Then stir the conical flask very well. How to stir? Hold the conical flask at this place. Hold the conical flask at this place. And shake the conical flask very well. Shake the conical flask very well. Okay, then add second drop. Then shake the conical flask very well. Then make the burette solution to flow into the conical flask drop by drop, and continuously shake the conical flask solution. Then the till end point is obtained. End point in the sense reaction is completed. Reaction is completed. How to know whether the reaction is completed or not? In the sense indicator we are adding, that indicator will show change in color. Indicator will show change in color. Sometimes self indicator will be there. That means either of burette or pipette solution itself show change in color. Okay, from that we can come to know the reaction is completed. Okay, this process is called titration, we can say. So now we got how to do titration. We got now using this titration we can find what? In the sense this titration, using this titration we can find a end point. We can find end point in the sense reaction is completed. That's what we can come to know it. So now in this titration we are using indicators. What about indicators? What is meant by indicators? What are the types of indicators? That we will see. Okay, so first we will take indicator. What is the use of this indicator? In the sense this indicator is showing change in color at equivalence point. At equivalence point. Okay, now see, indicator can be external substance, otherwise self. It will show change in color at equivalence point. What is equivalence point? At this point, reaction is completely over. Reaction is completely over. Just before we have used some other term. What is that? Endpoint. Just before we have used endpoint. What is endpoint? Endpoint means it is nearly equal to equivalence point. Endpoint means it is nearly equal to equivalence point. That means endpoint sometimes exactly equal to equivalence point, sometimes less than equivalence point, sometimes greater than equivalence point. Okay. Therefore, which point exactly indicates reaction is exactly over equivalence point. Equivalence point indicates reaction is exactly over, but end point indicates almost closer to completion of reaction. Sometimes equal to completion of reaction, sometimes closer to completion of reaction. Like this only end point will be there. Okay, sir. So now using indicator, we will consider that we are finding equivalence point. Otherwise, we are finding end point. Like this will take. Sir. Now, what are the types of indicators? One is called acid-base indicators. Acid-base indicator means burette solution is base, pipette solution is acid, then indicator is acid-base indicator. Indicator what in the sense phenolphthalein, methyl orange. It like this indicators we will add, which is used for acid-base titration. So, next, precipitation titration. Precipitation titration in the sense in the burette solution, silver nitrate solution, pipette solution, sodium chloride solution. What is precipitating? AgCl is getting precipitating. Okay, that is called in that place we will use precipitation indicators. We will use. So, why to use precipitation indicator? Precipitate itself we are able to see. Then why to use precipitation indicator? Precipitation we are able to see, but can we see starting point of precipitation? No, we cannot see starting point of precipitation. Therefore, indicator is required which will indicate starting point of precipitation. Okay. Then redox indicators. Redox indicators in the sense one solution will undergo oxidation, another solution will undergo reduction. Here titration means two solutions is required. No, one solution will undergo oxidation, another solution will undergo reduction. Then this reaction is called, this titration is called a redox titration. The indicator used in that case is called a redox indicator. Set. So types of indicators like this. Now some of the indicators we will discuss. One of the indicator we are taking is a phenolphthalein indicator. We are taking phenolphthalein indicator. Phenolphthalein indicator we have taken. What is the structure of this phenolphthalein indicator that we will see? Now we will take a like this phenyl ring we will take. It is bonded with a C double bond O. This is bonded with O. This and this bonded with one carbon. It is bonding with one phenyl ring. Here at para position OH group is present. Next, another this carbon is bonding with another phenyl ring. Here 5 bonds let us give. Okay, like this will be there. This is called a phenolphthalein. Now you say this phenolphthalein is a organic compound or inorganic compound. This is a hydrocarbon derivative, therefore organic compound. Sir, which are called organic compounds? Hydrocarbons and its derivatives are called organic compounds. Hydrocarbons means that compound contains which elements? Carbon and hydrogen. Derivatives means what? Using hydrocarbon, what are the compounds you are deriving? That is called the derivatives of hydrocarbons. Okay. Therefore, this compound we can call it as a organic compound. Okay. This compound is able to give H plus. Therefore, it is called acid. So we can call this is as a organic acid. We can say this for this Ka value, acid dissociation constant is very low. Therefore, we can say it is a weak organic acid. It is a weak organic acid, we can say. Sir, now this weak organic acid can donate H plus. It can give H plus. It is acid, therefore it is giving H plus. Okay. So that H plus, it is giving H plus, from where we will see this bond is shifting, therefore it is giving a H plus, we can say. So this hydrogen will be coming out as H plus. So rest of the part we will write. We are writing rest of the part. First phenyl ring we have written, here C double bond O, here O, here carbon. This is bonded with one phenyl ring. Here what will be there means OH group will be there. Here what will be there means phenyl ring. Here what will be there means O minus will be there. This O will have 3 lone pairs. And here pi bonds will be there. Okay. This O will have 2 lone pairs. So like this is there. Next, it goes for resonance stabilization. This lone pair becomes pi bond here. This pi bond goes to this place. This pi bond goes to this place. This pi bond goes to this place. Okay. Like this possible. Now, here we said this lone pair becomes pi bond. Okay. Sorry. This lone pair becomes pi bond, we are saying. So lone pair becomes pi bond here. Lone pair becomes pi bond in the sense, for this oxygen one electron is lost, therefore we have to give +1, already -1 is there, therefore net charge becomes 0. So we can remove this minus charge. Okay. Next, this pi bond goes to this place. Okay. This pi bond goes to this place, that we will write. So this pi bond goes to neighboring place. So neighboring place we have drawn. Next, we can say this pi bond goes to this place. Okay, this pi bond goes to this place, we are saying. Okay, in this place. Next, this pi bond goes to this oxygen as lone pair. Sorry. So this pi bond goes to oxygen as a lone pair. Okay, oxygen as lone pair. Therefore, oxygen gets a negative charge. Okay, so therefore, if this phenolphthalein is donating H plus and converting into so and so species, so and so species. Why we have converted like this? For what reason we have converted like this? Previously we got one anion, no? Like that itself, why didn't we leave? Why we have converted like this? Here C double bond O. Previously what species we got? Previously we got like this species, like this species, isn't it? Like this species. Why we have converted like this? Why to convert this species into like this species? What is the reason? That means this is having higher stability when compared to this. This is having higher stability when compared to this. That's why we have converted this species into so and so. Sir. So we are saying that it is having higher stability when compared to this, we are saying. How do we say this is having higher stability when compared to this? That means now we will take a carboxylic acid. We are taking carboxylic acid. This carboxylic acid is giving carboxylate anion and H plus. It is acid, therefore it gives H plus. Then we will take phenol. We are taking phenol. We are taking phenol like this. It is giving H plus. It is giving H plus and becomes phenoxide. For this equilibrium constant is less. For this equilibrium constant is high. Therefore, it is having higher stability. It is having lower stability. So that